Multiplying probabilities. This lesson is all about different ways to find probability. And the first word we're going to talk about is if we have independent events. These are two events that have no effect on each other. So a good example is if we roll a die. Right, you could roll a die once and you get a number 1 through 6. If you roll it again, the fact that I got a 2 the first time has no effect on what I'm going to get the second time. Right, if I roll it again, I might get a 2, I might get a 3, who knows? Right, they have no effect on each other. That's independent events. And that's very different from dependent events, which we'll talk about a little bit later, but let me give a little intro. Dependent events do have an effect on each other. So we've been talking about, what if I have a bag of marbles, and let's say we have 3 red, we have, I don't know, let's say 2 blue. If I pick a marble out and I happen to get a red marble, so let's say I pick one out and I got 1 red marble, now there's less marbles in the bag. Now there's only 4 marbles in my bag. So next time if I try to pick out a marble, my total is only going to be 4 compared to the 5. That affects it, right? You pull the marble out, there's 1 less marble. That's called a dependent event because the odds of the first time affect the odds of the second time. Right now we're going to focus on independent events where they don't affect each other, like rolling die or flipping coins, where what you do the first time has no effect on what you do the second time. And we have a formula for it, one I would always give you. It's a very basic formula. If they're independent events, then the probability of A happening then B happening is just multiplying A times B. Very simple. If they have no effect, you just multiply probabilities. So like here, a coin is tossed and a die is rolled. What's the probability of the coin landing on tails and rolling it head? So we want probability of getting tails. Now when you toss the coin, there's only 2 choices, heads or tails. So remember our general rule is 1 over total. We have 2 total choices and I want tails, there's only one of those, so that's 1/2. Right, odds of getting tails when you flip a coin is 1/2. And we're going to multiply that by odds rolling a 3. Remember when we roll a die, there's 1, 2, 3, 4, 5, 6 choices. And we want the 3. So there's only a 1 out of 6 chance of getting that. So if I flip a coin and roll a die, odds of getting a tails and rolling a 3 is 1 out of 12. That's the general idea. By the way, that's what, when we talk about rolling die in general, like if I go, what's the odds of rolling a 3 and then rolling a 3 again? Getting 2 3s. Well, there's only a 1 in 6 chance of getting 3. And then we're going to roll it again, has no effect. I have a 1 in 6 chance of getting a 3. So I have a 1 out of 36 chance of getting 2 3s. So that's the way independent events work. Now we talked about earlier, what if we do dependent events? Right? That means the answer from first affects the answer from the second. Dependent events. So in this case, let's look at an example here. A bag contains 12 red, 9 blue, and 11 yellow, and 8 green. That's a lot of marbles in that bag. So let's see, that's 20, that's 20, so 40 marbles. We have 40 marbles total. If 2 marbles are drawn at random and not replaced, so key thing, not replaced, so we're not going to put them back. You pick a marble, you get the marble, you keep the marble. What's the probability that a red and then a blue marble is drawn? So let's do this. We want to do red first. Probability red, and then probability blue. Now when I first pick out, we have 40 marbles in there, and now I'm trying to get a red marble. Well, there's 12 red. That's the first time, so I got my red marble. Now the second time, remember we're not putting this marble back. Now there's only 39 marbles left, because I took a red out. And you want to know what's probably getting blue? Well, how many blue are there left? There's still 9. I didn't pick a blue out yet, so there's still 9 blue marbles there. You multiply those together, and you get some number. That's the answer. That's dependent events, right? So what happens the first time affects what happens the second time, right? You lose the value here. Independent events, they have no effect on each other. You just multiply them together. So let's look at this. There are 8 action, 3 comedies, and 5 drama DVDs. So we have total of, let's see, 8 plus 8, 16 DVDs, because it must be 1994. Suppose 3 DVDs are selected at random from the shelf, find each probability. So what's the probability you get 3 action? So we're going to take 3 action movies with replacement. So with replacement means you put it back. So let's do an example. So I have 16 total DVDs. I want to get an action movie. So there's 8 of those. So it's 8 out of 16. Now with replacement means you grab it and you put it back. So there's still going to be a total of 16. Just put everything back. You go back to, like, basically it means you reset. Back to starting, right? So we're back to normal here. So what's the odds of getting an action DVD? Well, 8 again. And then the third time, we're replacement, we're going to put everything back. We reset it to the beginning. And you have an 8 out of 16 chance. We could simplify this. I could do this on my head. 1/2, 1/2, 1/2. So I get a total of 1 out of 8 chance of getting 3 action DVDs. Now let's look at this one. They want 2 action, then a comedy without replacement. We take the DVD, we keep it with us. So for the first action, there's 16 movies and there's 8 action. So I got my 1 action. Right, now for the second one, we want action again. But now it's without replacement. So I don't put that action back. I keep that movie. There's only 15 total movies. And I picked an action already. So there's 1 less action movie. 7. So now there's 2 action. And then for the last one, I want a comedy. Right now there's only, again, I took 2 DVDs out. There's 2 less now. So there's only 14 total. And I want a comedy movie. I haven't picked a comedy yet. So how many comedies are there? There's 3 comedies. So they're all still there. And I just multiply this out and you get some number as an answer. I mean, if we actually want the actual number, I could waste like 20 seconds and bring calculator out. It's supposed to go faster than this, right? And then I could turn it on. I'm gonna go 8 divided by 16 times 7 divided by 15 times 3 divided by 14. Odds of getting action, and comedy is gonna be 0.05. Remember, if you want to make it a fraction, very simple. Just go to math, hit fraction. 0.05 you should know how to do. It's 5 over 100, which 1 over 20. But you know, whatever. So you get that. Or 0.05. Either way it works. I don't care. Decimal fraction's all the same to me. So that's dependent, right? So dependent, odds change. Independent, you just multiply across. Now the next we're going to do is a little more complicated than that. And that's called conditional probability. Conditional probability is all about if something happened, what's the odds of something else happening? So conditional. If A occurs, what's probably B occurs? So over here it says, if I said, if on the first 2 tries I got action, what's the probability on the third I'm going to get a comedy? So the answer to that would be 3 out of 14, because the first 2 times I got action. So now there's only 14 DVDs left, and odds of getting a comedy, 3 out of 14. That's the idea of conditional probability. Conditional probability is also known as given that. That's the form we're going to use. And that line right there means given that blank happened. So this one says, was probability B happens given that A happened. So A happened, was probability B happened. It's this formula right here. A intersection B times probability of A times this. Again, we'll use it. I'll give you that formula. We're going to use it a lot. So you'll have it. Just kind of know how to use it. So this first example. At a restaurant, 25% of customers order chili. So 25% order chili. 4% of customers order chili and a baked potato. Find probability that someone orders chili and also orders a baked potato. So what they're saying is, find probability that if someone orders chili, they also order baked potato. So baked potato. What's the probability of potato given that, you know, someone orders chili? So we're going to use the formula, which is probability of the intersection, potato and chili, equals probability of the second one, the given that, which in this case is chili, times what we're looking for, probability of baked potato given chili. So this is what we're looking for. I'll put an X right there because we want that. Probability of chili, they actually told us in this problem. At a restaurant, 25% of the customers order chili, so 0.25. And potato and chili, right here, 4% orders chili and a potato, so 0.04. Now we're all set up. Just got to divide by 0.25. And I get my probability here is 4 over 25. And you get that, which is about 16%. 6% chance if you order chili, you can order baked potato. This next one. Suppose the probability that a student takes AP calculus is on the honor roll is this percent right there. So this is saying, hey, you take AP Calc, good class, and you're on the honor roll. That's gonna be that right there. You're doing both. That odds you're in both AP Calc and honor roll. That seems really low. Is it just me? Anyway, probably that student is on the honor row is this one, so it's probably on the honor row. That's 0.23. Final probability the student takes AP Calc, given that keyword, woo, he or she is on the honor roll. So we're looking for probability AP Calc, given honor roll. So let's use the formula. Again, it's right up here. I will give it to you so I know how to use it. It's the intersection equals the given that times what probability of what you're looking for. So just using the formula, it's going to be probability AP Calc intersection honor roll equals probability of honor roll, because we're looking for probability AP Calc given honor roll. Right, so whatever this one is the one that's by itself. And then again, it's all given to us. This right here is that extremely low number of 0.0035 equals probability honor roll, which is 0.23, and this is what we're looking for. So you divide, and you get x equals 0.00235 over 0.23. By the way, if you're trying to make this without decimals, you just move it over 4 spots. Move this over 4 spots, and you get 35 over, add a couple zeros, 2300. That's a really known number. I protest that. Anyway, that's how you do given that. We'll do a little bit more in class, but that's the general idea of a given that problem. Now, two-way frequency tables. You're going to like these. So two-way frequency table is this. It's kind of all the same idea, but classified in a two-way frequency table, which is this right here. So here's an example where we have treatment, control, condition improves, condition does not improve. So we have like right here we have two things. We have what happens there. So there's one key to a two-way frequency table, and that is find the totals of all columns and rows. All columns and rows. So that's the key to a two-way frequency. You got to find the total. So if I'm doing this, before I even do anything else, I'm going to put, hey, there's a total here, which is add these down. I get 2800. Add these down, 1200. I have to find the total here. Add these up, 2000. Add these up, 2000. And I get the grand total of 4000. So very first thing, to have two-way frequency tables, find the totals if you don't have them already. And once we do that, the rest of it's just like stuff we've been doing for the past couple lessons. So actually, let's go back to context of the problem. A drug company conducts an experiment to determine the effectiveness of a certain new drug. Test subjects were randomly assigned to one or two groups: a treatment group and a placebo group. I think a control group, which receives a placebo drug, which is like a fake drug. So here's the thing. So treatment. So people that got the treatment, 1,600 of them improved with the treatment. 400 didn't improve with the treatment. The one that got the placebo, about 1,200 improved, and 800 didn't improve. Okay, so let's answer these questions here. Find the probability that a test subject conditions improved given that he or she was in treatment group. So notice the given that again. So probability improved given that it was in a treatment group. Now we can do the same thing here, but I'm going to show you a shortcut to doing the given that in a table here. And that is, this is the world. This is the total. Right, so we're given that it's in treatment group. So I know he's in the treatment group. So the only thing I really want to look at is this right here. So that's why I said world first. The only thing I care about is the treatment group. So based on that, since I know I'm in the treatment group, my 1 over total, my total is 2000. Treatment group. And what do I want? I want improved. So how many people improved? 1,600. And there, we are done. Right, given that on these is actually extremely easy. Just go, okay, what's the given? Oh, okay, treatment. I'm only looking at the treatment people. And then this from there, fill your 1 over total. Let's look at the bottom one here. Find probably that a test subject was in a control group, given that he or she condition did not improve. So probability control, given that did not improve. So again, same idea. We know they did not improve. That's our total here. All we're looking at are the people that did not improve. So only people I care about. How many of them were in the control group? Control for that was 800. So my want over total is going to be 800 over 1200. And again, if you want, you can reduce it, but that's a general idea. That if they give you a given that is the only thing you're looking at. What's your want? What's your total? So another example. Driving tests. The table shows how students in Mr. Diaz's class fared on the first driving test. Some took a class to prepare, others did not. Find each probability. So again, first thing to do with this, we want to find our totals. So 64 plus 18, let's see, plus 6, 2, 1, 82, 0, 1, 80. So right, 82 people took the class, 80 people did not take the class. If you add them up, you get 162 is my total here. Add this way, that's 40, 50. And then I could do either way, but I'm going to go 112. So those are my totals. Again, I need that to know what I'm doing here. It's a 50. Kind of hard to see. I know my writing sucks. There we go. So A, Paige passed given that she took the class. So probability pass given that you took the class. Right, so again, what we're doing here is, okay, you know they took the class. So how many people took the class? And then what's the odds that you pass? So pass is 64, 64 out of 82. Next one, Madison failed. Sorry, Madison. Given that she did not take the class. So probability failed, should have took the class. Did not take the class, so no class. So again, this is what we're looking at. So no class, so people that did not take a class. So my total is 80. How many of them failed? 32. Just a statistic, Madison. So there's that one. And then the last one here, C. Jamal did not take the class. No class. Given that he passed. So Jamal didn't need the class. He passed anyway. Right? So we know he passed. So we're looking at the pass people. So now it's a block right here. My total to be 112. And how many of them did, and how many people did not had no class? 48. Again, so that's how you do given that if you have a box. It's a lot easier. Whatever the given that is, that's kind of the only thing you're looking at. That's your total. You're in that vein. Okay, now let's look at the next lesson that we're going to do here today. Now this one we're going to need a calculator. We're talking about measuring center, spread, and position. So all these guys probably learned in grade school. We're going to go over them again. And then we're going to go a little further with our calculator. So first thing, mode means most often digit ever, I guess. But most often digits, what I always remember. If I could spell it. Often digit ever. No, but, right? So most often digits. So when you see the most is the mode. So if I give you a list of numbers here, let's just do it. 2, 2, 3, 4, 6, 6, 7, 7, 7. My mode is the when you see the most, so 7. If the 7s weren't there, then it'll be 6 and 2. They both have 2. Right, so most often it's the mode. Means another word for average. We should all know how to take the average or the expected value, by the way, which is you add them up and divide by the total number. Right, you add them all of them up, sum, and divide by the total number. That's actually not a very good example. But anyway, if I was doing that one right there, right, let's go 2 plus 3, blah blah blah, plus 7, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide by 9. That's how you find the average, right? The mean or the average. Add them up, divide by your total number. So right there. Median is the middle number. So median is the middle. I just remember it because when I write it like lowercase, that's kind of in the middle. That's the way my brain works. Don't ask me why. So over here, right, there's 9 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The middle number will be 5. So 6 is my median here, right? Exactly in the middle of both of those. If there's 2 things in the middle, you just take the average. So if I had like 5 and 6 in the middle, I would just average them out. And that would be your median. So median is the middle number, means the average, mode is the most often digit. Range. Range is the max minus the min, right? Highest minus low is how far apart are your values. So over here, my range would be 7 minus 2 or just 5. Right? Range is the max minus the min. Next, let's do some examples. Now, doing this by hand doesn't take a little time. It'll be annoying. So we're actually, I mean, it's not that bad. You just use a calculator. But if we're going to use the calculator, let's go all the way with it. So I'm going to bring my calculator here. And let's show you how to find the mean, median, mode in your calculator. So we're going to turn it on. We're going to go stat. We're going to go edit. We're going to type in all this data under list 1. Ta-da, little movie magic. It's all in there. By the way, if you can do this by hand, first thing I do is list them out in order from lowest to highest so you can figure out the median. But we're going to use a calculator. So we're going to quit. I'm going to go to stat. Go over to calculate. And we're going to do one variable stats. So you see something like this. There's a list is L1. Frequency list. We don't have a frequency list. We'll do one later, but there's no frequency. Leave that blank. If it's something there, clear it out. Delete it. And then go to calculate. And it's going to give us this. Now, what does all this stuff mean? That first one's the mean. X the line over it, it's a mean symbol. So our mean already is 29.5. I believe that was before it went away. Is 29.5. The line over it. That's our mean. So it's a symbol for mean. Average. This right here just means the sum. So if you add all these up, what do you get? You get 295. If you add them up and you square them, in case you wanted that, you get that. Here's some other values. That's standard deviation and another standard deviation. We'll talk about that more later. And the total number of stuff you have. We had 10 total values. And then look how when you scroll down. There's the min. There's the max. If I want to find the range, I can subtract them. There's Q1, Q3. We'll talk about that in a second. And here's the median, 32.5. Now you know what you're saying. Where's the mode at? Well, sadly, your calculator doesn't do the mode. You have to figure it out yourself. You have to look at it. Which happens the most? It looks like 35 happens the most. I see it 3 times. I don't think anything else beats it. So 35. Most often digits 35. And that's the idea. This is the next one. We'll do this one too. Number of text messages sent each day during the last 2 weeks. Oh, that they did not get that from a high school kid. So look at number of text sent each day by your grandma in the last 2 weeks. So put these in, right? Stat edit. Let me hit pause and put these numbers. Actually, I want to talk about how to clear this. So I think we talked about it before, right? But if you want to clear the data, you put clear, not delete. If you put delete, you're gonna lose it. Clear clears it all, and now you can type them all in. Again, they're all in there. So now we could quit, go to stat. We're gonna go to one variable stats. Again, L1's list 1, frequency list. We're gonna leave that blank. We're gonna hit calculate, and again, our mean is 34.4. Our median is 35. So mean 34.4, median is 35 something, blah blah blah. And then the mode, we actually gotta do it ourselves. Let's see, 33. I see one. Okay. Pressure. I see 35 twice. I think that's the most. So when I see twice, it's 35. I'm gonna leave it like that and move on. Next up, quartile. So it's actually kind of important. So quartile or quartiles, what they are is they're your medians of the top and bottom half. So if we have our data, right, let's say this is our lowest, this is our highest, and right here's our median. The median of the bottom half would be our lower quartile. Median of the highest would be our upper quartile. Also known as Q1 and Q3. So those are the numbers you saw over there. So if I go back all the way up to our example way up here, right, now look down here. Of these 4, my lower quartile will actually be in between these two. So I gotta take the average, 2 plus 3 divided by 2, or 2.5. It's hard to see because it's all blue. Over here, same idea. My median of the top half would be right here, which that's easier. It's just 7. This will be my lower quartile and my upper quartile, Q1 and Q3. That's all quartiles are, top half and bottom half. So lower quartile is known as the bottom 25%. Because if you divide it in half, it's 50. If you divide it in half again, it's 25. Upper quartile is the 75th percentile. So again, 50 divided in half, 75. So that's where the top 75 people are. That's where the bottom 25 people are. The interquartile range. It's a fancy name for a lot of IQR, we call that. It's a fancy name for Q3 minus Q1. Upper quartile minus lower quartile. So you see it right here. It lets you know where the middle 50% of your data is. So this is where most of your data falls. Middle 50% of data. So this really quickly, if we went back up here, right? I got back my calculator. If I scroll down, here's my upper quartile 44. Here's my lower quartile 21. If I want the IQR, just subtract the two, and I get about 28. So that's upper and lower quartile. Now, why is that important? Because this is how we make a box and whisker plot. So if you ever heard of a box and whisker plot, it's something that looks like this. You have a line. You put a whisker. This we call this a whisker. We put a dot here at the lowest, the min. Put a dot here at the max. Wherever the median is a line. Wherever Q1 is your lower quartile, we'll put another line. Whatever Q3 is, we'll put another line. You connect it, and we get our box and whisker graph. Right? And why is that important? Because that tells us where the middle 50% of data is really easily. It tells us where the min and max is. So that's what that is. These are the important data sets for a box and whisker plot. We call that the 5-number summary. And all that has to do with, do you know the median? Do you know the max? Do you know the middle? Do you know the lower quartile, upper quartile? Right, it works both ways. If I see this, I'm like, okay, the min is 1. The max is 15. My median is a line right here, 6. My lower quartile is 4. My upper quartile is like 9.5. Right, so very easy to tell what all those important values are straight from seeing a box and whisker plot. And you also do is like, what's the lowest, what's the score for the lowest 25% of the class? Right here, Q1. What's the highest 25% of the class? That'll be right there, Q3. So stuff like that. So next, let's make our own box and whisker plots. So if we have our soda we did from earlier. We should thought this ahead of time. So I'm going to type all those back in, and we'll make a box and whisker plot out of it. Here's my calculator. I typed it all in. So next, we're going to go quit, stat, calculator. Go down. Oops. Where am I going? Stat, calculator, one variable stats. I don't know where I was going there. L1, right? Leave the blank, no frequency list yet. Then we go to calculate. We're going to hit that number. Now again, all I want is a 5-number summary. Well, actually, so we're going to find the mean. We don't need the mean. We're just going to 5-number summary. Scroll down to the bottom right here. This is all we really need. Right? We have the min 10. We have the max 50. Q1, Q2. So I'm doing this. Let me write it down. Min is 10. Max is 50. Put Q1, Q2, which is a median. There's a Q2, so it's median. Q3. My values are 20, 32, and 35. Yeah, I noticed 0.5. Right, so we have that. We draw a line. Hopefully your line is actually a line, not like mine. Right, the lowest is 10. So like if I had a number line here, it would still extend. My highest here is 50. 32, oh, it really works if I had like a number line. So let's say 20, 30, 40. My Q1's 20, so this is going to put a little line there. My median is 32, so this is supposed to be 30, so 32 is supposed to be my median. It's like right there. And then 35, so this is supposed to be 40, so like right here. And you make a box out of it. Right, and that's a box and whisker plot. I see the lowest is 10, highest is 50. This should be labeled 20. This should be labeled 32.5. This should be labeled 35. And you can see in most of the data here, people score below the median. And actually, since we're here, let's find the IQR. Right, IQR is this Q3 minus Q1, upper quartile minus lower quartile. So this is 35 minus 20 and 15. Most of the data falls 15 points, between 15 points right here. And that's that.